Well, I'm going to let you figure out why. You should go onto Google and ask the question, why does ytterbium sulfate decrease in solubility as the temperature increases? It's a very interesting reason, and perhaps it's a bit counterintuitive to what you guys may understand about this so far. Well, then we have factors that affect the rate of dissolving. Wait a second, we actually need to finish this first part first. So, so what are the effects of pressure on solubility? Okay, well, first one, pressure doesn't affect the solubility of most solutions, except for gases dissolved. If we're trying to dissolve a gas, then the amount of pressure on the top of the solution is going to affect the solubility. And the solubility of a gas increases as the pressure of the gas is increased over the solution. Which sort of makes sense. Think about pressure of the pressure over the top of the solution as forcing the gas into the liquid of the solution. If you have more pushing onto the top of the solution, you're going to get more of it is going to give, and more of it is going to get into the solution itself. Okay, so what are the factors affecting the rate of dissolving? Okay, so these factors actually have their basis in the kinetic molecular theory from last chapter. The rate at which a substance dissolves in a solution depends on three factors. The first one is the surface area of the particle. Okay, so as particle size gets smaller, the surface area increases, which causes the interaction between the solute and solvent increasing with greater surface contact. And the smaller particles will dissolve faster than the larger ones. That's essentially what this means. But the idea behind it is when you have a solute getting dissolved into a solvent, particularly a solid solute into a solvent, the only place where you have interaction between the two substances is on the very surface. So if we get this solute here, okay, we'll say it's a square, it's like it's a salt crystal. The only place where that happens is out here on the surface of the solute, and not in here. In fact, the pieces have to get carried away after the collisions of the solvent molecules with the solute particle, which will eventually eat away till you get to the center. It's kind of like a Tootsie Roll that you have to lick away on the outside before you can get to the soft, chewy interior. But that's really what happens when you have a solute dissolving in a solvent. You have to have the external interaction before you get to the inside stuff. Okay, so the next factor that's involved is stirring. Okay, and stirring increases the interaction between solute and solvent. Okay, so if you mix them up a bit more, then the stirring or agitation will actually increase the rate of dissolving. Okay, however, this is only true for ooh, that was not good. It's only true for solids and liquids into liquid solvents. Okay, not gases. Okay, because the more you stir a gas into a solvent, the more it will come out. Okay, which brings us to the last one, which would be temperature. If you increase the kinetic energy of the particles that are in the solvent and in the solute, that increases the interaction between the solute and solvent. So next page here. Okay, which will result in a faster dissolving time, because the solvent particle will move faster and more quickly. However, once again, this only works with solids and liquids. This is not gases. In fact, it has the opposite effect with gases. And you've seen this before. What happens if you open up a hot bottle of soda? It spews out, and the gas comes out more readily. And this is because the gases already have a high kinetic energy, or they would when they are not dissolved, and they'll expand and release very quickly. Okay. Now, for a saturated solution, now we need to talk about saturation, which is the next point. Saturation has to do with the solubility of a particular solute in a solvent. So, saturated solutions contain as much solute as can possibly be dissolved at existing conditions of temperature and pressure. When more solute is added, it just sinks to the bottom. Okay, this is okay. Now, we already have a term for the amount at which the amount of solute that you would need in order for it to reach saturation. And it is called, right here, solubility. It is the amount of solute that will dissolve in a solvent at a specific pressure and temperature. Okay, so we talked about solubility earlier. A saturated solution contains an amount of solute that is equal to its solubility. All right. Then we have an unsaturated solution. And this is just any solution that contains less than this amount of solute that's dissolved under specified conditions of T and P. Okay. Then finally, we have the really cool one, which is called a supersaturated solution, which is a difficult word for me to say considering my S's. It contains a greater amount of dissolved solute than what's needed to form a saturated solution. Okay, which means that there's actually more stuff dissolved in the solution than can theoretically be possible to dissolve. So it's not like it's an absolute zero, absolute no, you can't get slower than that. That you can go over the saturation amount, but only under certain circumstances. Okay, and you make them by dissolving excess solute at higher temperatures and then allowing the solution to cool very slowly to prevent recrystallization. And for example, that's how we make rock candy, which we won't be able to do in here. But it's when a seed crystal is added, the excess dissolved solute precipitates out. Okay, and here is the picture of the sodium acetate that lecture refers to, right here. This is a supersaturated solution of sodium acetate, and that is a seed crystal right there. And when the seed crystal is placed into the solution, it instantly creates sodium acetate crystals, more of them, and it grows off of the seed crystal until all of it precipitates out, or all of the excess sodium acetate that is in solution precipitates out. So what is left? In fact, that is a question I'm leaving to you guys, is what is the amount of sodium acetate what is left dissolved in solution? Is it all of it? Or hold on, let me rephrase that. Okay. Does all of the sodium acetate precipitate? does all of it precipitate out? I'll tell you right now, the answer is no. But I want you to tell me why, and I will be stamping this. If you are watching on just the video, I will be asking this question in class and stamping when you guys have an answer. Okay, so that's it for 16.1, and this is P-Dog signing out, and I'll see you guys next time.